Hey, guys, in this video you will learn, how electricity does it work. This is a very basic concept that every electrical engineer must know. So, let's start at the very basics. For that, we need to understand the atom first. Everything, including us, is made of atoms. All the materials we use are made of atoms. The materials are just different because the construction of their atoms is little different materials. The atoms are made from 3 particles, 2 of which are found inside the nucleus. And the third particle sits outside this. There is a nucleus at the center of the atom. Inside the nucleus, we have the neutrons and protons. Neutrons have no charge, and protons are positively charged. The neutrons and the protons are much heavier than the electrons, so these will stay within the nucleus. Surround the nucleus are different layers of orbital shells. These are the paths for electrons. The electrons flow along these paths much like a satellite orbits our planet, except that the electrons travel at almost the speed of light. Electrons are negatively charged and they are attracted to the positive charge of the protons. The electrons orbit around the nucleus in these orbital shells, and there are a set number of how many electrons can be in any one orbital shell. The number of protons, neutrons, and electrons an atom has tells us which material it is. Atoms hold on to their electrons very tightly, but some materials will hold on to them more tightly than others. The outermost shell is known as the valence shell, and in this shell, some materials have loosely bounded electrons that can flow to other atoms. Atoms that can pass electrons are called conductors, and atoms which do not have free electrons and can't pass electrons between other atoms are known as insulators. We use conductor materials to pass the electricity and insulator materials to unpass the electricity. We can combine these materials to safely use electricity by having the conductor in the center, which allows electrons to move, but surround this with an insulator to restrict where they can flow to. If we look inside of copper cable, the free electrons surrounding the nucleus of the copper atom can move to other atoms, but this happens randomly in any direction. If we then connect this copper cable to a closed circuit with a power source, such as a battery, then the voltage will force the electrons to move in the same direction to try and get back to the other terminal of the battery. We can add things into their path, like light bulbs, and this means that the electrons will have to pass through this to get to the other terminal. The circuit can either be opened or closed. In a closed circuit, the electrons can able to flow around. But in an open circuit, electrons are not able to flow. Voltage is a pushing force that forces the electrons to flow within a circuit. It's like pressure in a water pipe. The more pressure you have, the more water can flow. The more voltage you have, the more electrons can flow. What does a volt mean? A volt is a joule per coulomb. And a joule is a measurement of energy or work. Current is the ratio of the flow of electrons. When a circuit is closed, it means electrons can flow, and when the circuit is open, no electrons will flow. We can measure the flow of electrons just like you can measure the flow of water through a pipe. To measure the flow of electrons, we use the unit of ampere. 1 amp means 1 coulomb per second, and 1 coulomb is a group of electrons. That's why electrons are grouped together and just called amps, to make it easier for engineers. Resistance is a restriction to the flow of electrons in a circuit. The conductor which carries the electrons will naturally have some resistance. The longer the conductor, the greater the resistance. The thicker the conductor, the lower the resistance. Resistance to the flow of electrons is different for each material. And the temperature of the material can also change resistance to the flow of electrons. Electrical circuits use specially designed components known as resistors to purposely restrict the flow of electrons. This is either to protect other components from too many electrons flowing through it, or it can also be used to create light and heat. When a wire is wrapped in a coil, it will generate a magnetic field as the current passes through it. The cable will naturally create an electromagnetic field by itself. By wrapping it in a coil, the magnetic field becomes so strong that the magnetic field starts to actually affect the electrons within the wire. And this is how electromagnets work, and it's also the base of how induction motors work. So, this was the basic introduction to electricity. In our upcoming videos I shall explain all electrical devices' construction and working principles. Keep watching Technical Library and chill.